Welcome. So far in our previous discussions, we have been discussing about single phase load power measurement using wattmeter, and we have seen a lot of aspect of using a current coil, pressure coil, their connections, and how to find power and error using the problem solving approach. Now in this lecture we are going to deal with the three-phase load and try to measure the three-phase power using wattmeter. Now in this diagram we have a three-phase load. Three different load is connected with three different phases, that is R, Y and B. Now if we want to measure the power consumption of this entire three-phase load, then we have to connect wattmeter with the phases. Now how could we do that? There is two approach. First is connect three separate wattmeters with each phase. Now how could we do that? Connecting a current coil with R phase and a pressure coil in parallel with R phase. Similarly, connecting the current coil with other two phases and a pressure coil in parallel with the phases and connecting all of them with a neutral connection. This is the neutral. So in this way we can connect three separate wattmeters in the line and calculate the entire load consumption. Suppose this is wattmeter 1, this is wattmeter 2 and this is wattmeter 3. So if we want to determine the entire consumption of this three-phase load, then our consumption of power is equal to W1 plus W2 plus W3. If we add the individual wattmeter readings, then we will calculate the total load consumption or power consumption of the three-phase load. This is the three-phase load. Now secondly, there comes another method called two wattmeter method. Now before going into two wattmeter method, one thing I have to mention here, that this method or this two method is applicable for the load being in star and delta connection both. This is the star connection. The loads are connected in star formation, and delta connection means when the loads are connected in delta format like this. Okay, so your power consumption method of using these two techniques is applicable for both star and delta connections. Now next is two wattmeter method. Two wattmeter method means this is the circuit diagram of two wattmeter method. So if there is three-phase loads is connected with three different phases, then we can measure the load consumption of this R phase, Y phase and B phase by using these two wattmeters, that is W1 and W2. Now you would say, how it is possible? See, our total power is power consumed by these individual three loads. Now what is the wattmeter 1 reading or W1 reading? W1 reads voltage between R and Y phase and current in R phase. Why? Because this pressure coil is connected between the phase R and Y. Pressure coil is used for determining the voltages, and what is the voltage? The potential difference between R phase and Y phase, so that it is VRY and IRY. IR because the current coil is connected with R phase, so the current coil will determine, or the current coil will measure the value of the current through R phase, that is IR. That's why the wattmeter 1 will read VRY into IR, that is equal to VR minus VY into IR. Clear? In similar logic we can write wattmeter 2 will measure VB minus VY into IB. Now what is our objective? Our total power or total load consumption is equal to P equal to VR into IR. plus Vy into Iy plus Vb into Ib. This is because power is equal to voltage into current. I have earlier mentioned it. Now if you go for addition of W1 plus W2, then you can obtain this much of power or this relation by adding the two wattmeter readings. That means your W1 plus W2 is equal to your total power consumption of load, that is P. All you need to do is to use these equations, that is equation 1, equation 2, and you will automatically find that your total power consumption is equal to the relation of summation between the wattmeter readings W1 and W2. Clear? Now understand this concept with a problem solving. Two wattmeters are connected to measure a power consumed by three-phase balanced load. One of the wattmeter reads 1500 watt, another wattmeter reads 700 watt. So suppose let us take W1 reads 1500 watt and W2 reads 700 watt. When both the readings are positive, then find the power factor of the load. Okay, to solving this kind of problem, we have to deal with two different type of formulas. One is total power that we have learned earlier, equal to W1 plus W2, first formula. Next is phi is equal to tan inverse root 3 into W1 minus W2 by W1 plus W2. Now what is phi? Phi is the angle between voltage and current, or you can say it the power factor angle. Now first we have to determine the value of power factor. For that, first we need to determine the value of phi. So phi equal to, simply we can use the relation here like this. From here we get the value of phi is equal to 32.2 degree and power factor is equal to cos phi equal to cos of 32.2 degree, that means 0.846. This is your power factor for the first case given in the question. Now what is the second part? The second part is when the reading of the second wattmeter is obtained after reversing its current coil connection. See, whenever you are reversing this current coil, that means your current coil connection should be like this. This will be your current coil connection. If at the first case the polarity of the current coil is, suppose this is X and this is Y, then after reversal the polarity will be, this is Y and this is X. So whenever you are reversing the polarity, that means the direction of the current, if previously it was IB, now after reversal it will be minus IB. So whenever the value of the current is negative, then the reading at wattmeter will also be reversed. That means the reading of your W2 will be minus 700 watt. Now your question will be why? Because power is equal to voltage into current into cos phi. So if you are reversing the value of the current minus I instead of only I, then automatically the expression will be minus Vi cos phi. Clear? That is why the negative sign has arrived before the reading of the wattmeter. So for case 2, your W1 will be 1500 watt and W2 will be minus 700 watt. Clear? Now what is our objective? Again, determination of power factor. For that we have to determine the value of phi first, that is like this. From here we get the value of phi is equal to 78.1 degree, and if we take the cosine of this angle phi, that is equal to 0.21. So after reversal of our current coil, we get the power factor value decreases to 0.21. Now you calculate reversing both current coil connection and find whether the value of cos phi or power factor remains same as case 1 or changes. You mention this in the comment section below after calculation and see how the reading differs or whether it is remains same after alternating the current coil connections. Thank you.